Lessons in Logic video 20, if I'm not mistaken. And in this video, we're going to learn some of the basics of Venn diagrams. Now, we want to eventually work up to Venn diagrams with 3 circles, but we have to start with the basics. That means Venn diagrams with 2 circles. This video will assume some knowledge from former videos. It will assume that you have some working understanding of what the modern perspective is. We're doing Venn diagrams using the modern perspective here. Now, actually, it might be appropriate to do a very brief review here. The modern perspective on existential import is that universal propositions do not imply that the things they're talking about exist. For example, in other words, if I say all guinea pigs are mammals, I'm not actually stating that guinea pigs exist. I'm just stating that if anything is a guinea pig, then it is a mammal. All right, so we're going to learn how to do Venn diagrams using the modern perspective, not the old school Aristotelian perspective, on which it would be presumed that a statement like all guinea pigs are mammals implies that if anything is a guinea pig, then it is a mammal, and also implies that some guinea pigs really do exist. Those are different perspectives in philosophy of language, and they affect how we use some of our methods, and they're going to affect how we use this method. And we're going to learn the Venn diagram method using the modern perspective. And the Venn diagram method is very neat. It's one of the coolest way of testing categorical syllogisms for validity. And a categorical syllogism will have 2 premises, and it will have 3 terms. A categorical argument using only 1 premise is what we call an immediate inference in categorical logic, and an immediate inference can sometimes be tested for validity using a Venn diagram. I'll have to check my notes and make a new video on that, or include it in this video, depending on what I find in my notes on the subject. I don't want to leave that out entirely, but our goal is to work up to using Venn diagrams for categorical syllogisms. But first, we have to learn how to do Venn diagrams for categorical propositions. All right, so learning the basics of Venn diagramming, let's learn this first. The 4 different forms of categorical proposition, A, E, I, and O, can all be illustrated by Venn diagrams. A Venn diagram has 2 overlapping circles, 1 for each term, and it's actually 2 or 3 overlapping circles. If you're doing 1 categorical proposition only, it's going to be 2 overlapping circles, and if you're doing 2 categorical propositions, you're going to need 3 overlapping circles. Actually, maybe not. It depends on what your categorical propositions are. If you're doing a standard Venn diagram for a categorical syllogism, you'll need 3 overlapping circles. What matters is how many terms you have. In 1 categorical proposition, you always have 2 terms. So it's always a minimum of 2 circles, and it's a minimum of 2 circles for a categorical proposition. And for that proposition as such, it's just 2 circles. Only 2 circles are concerned with diagramming a categorical proposition. But if you're dealing with 2 categorical propositions that include a total of 3 terms, which is normal in a categorical syllogism, then you have 3 circles. So to make this a little more concrete, since my brain, like probably your brain, works better with example than with me just trying to state these things in generalities. If I say all guinea pigs are mammals, and I'm going to Venn diagram that, I'm going to need 1 circle for guinea pigs and 1 circle for mammals, right? But if I say all guinea pigs are mammals, no mammals are sharks, therefore no guinea pigs are sharks, I'm going to need 3 overlapping circles, 1 for mammals, 1 for guinea pigs, and then a 3rd one for sharks. So a Venn diagram has 2 or 3 overlapping circles, 1 for each term, 2 when we're just doing 1 categorical proposition, and that's how we do the basics. We're learning the basics right now. And in a Venn diagram, you shade a region to indicate it's empty. Shading does not indicate fullness, it indicates non-existence. Remember that. That's crucial. This is one of the more natural mistakes in the use of categorical logic, to think that shading indicates fullness. You're filling in a category, therefore the category is full. No, the category is completely empty. If you've shaded a region, that means there's nothing there, but you put an X in a region where something does exist. And if you're thinking, well, what about a region that is full? The answer is, I don't know, it doesn't matter. It doesn't come into categorical logic. In fact, I don't even know what it means to say that a region is full. But I do know what it means to say shade a region to indicate nothing is there. Put an X in a region to indicate something is there. X, it marks the spot X marks the spot where something exists. Now, this is how we would use Venn diagrams on the Aristotelian perspective, and it would be a perfectly useful way of, well, not perfectly useful, but perfectly acceptable and very useful way of doing categorical syllogisms if we adopted the Aristotelian perspective. We could have learned this. It would have been fine. But there would be extra steps. There would be extra complications because you have to include more information for the Aristotelian perspective. Because remember, the Aristotelian perspective, the older philosophy of language on this existential import question, has it that a statement like all guinea pigs are mammals is telling us, one, if anything is a guinea pig, then it's a mammal, and two, some guinea pigs exist. Whereas the modern perspective says that a statement like that is only telling us, one, if anything is a guinea pig, then it's a mammal, full stop, nothing else. It's not telling us any guinea pigs exist. So the Aristotelian perspective has it that there's more information in some categorical propositions, and so you have to include more things. So the A-form proposition, any A-form proposition is going to, on the Aristotelian perspective, tell us that if anything is an S, then it's a P, and some S exist. In other words, there's nothing in that region that represents S's that are not P's, and there is something in that region that represents S's that are P's, because that's the only place for it to go. There is nothing that's an S and not a P, and so you shade the first region. So in the, if there's any difficulty seeing the screen, let's see, how can I adjust for that? If there is any difficulty seeing the screen, maybe I can zoom in, maybe that will help some. If there's any difficulty seeing the screen, I've zoomed in slightly, and I hope that helps. In fact, I will see if I can capture all of them, and you can pause at need. The I is just a bit off because of some minor mistake I made in the formatting of this image. Sorry. All right. Now let me describe what I'm saying in case there's any other difficulty. For the A form categorical proposition, you have two low overlapping circles, one representing the S term, one representing the P term, i.e. the subject and predicate term of the proposition. Oh, and if I haven't stated this explicitly in my notes, let me say it explicitly now, orally. When you're doing just two terms, just one categorical proposition, S term always on the left, P term on the right, subject term always on the left, predicate term on the right. So you've got two overlapping circles, one for the subject term and one for the predicate term. And that means you have three possible regions where you can diagram something. You have the S only region where S does not overlap with P. You have the S and P region where the circles overlap. Then you have the P only region where P does not overlap with S. And for an all S or P statement, then you want to shade the S only region to indicate there's nothing there. If anything is an S, then it's a P. And then you also, since on the Aristotelian perspective, and since that's what we're talking about here, this is how we would do Venn diagrams for the Aristotelian perspective. You put an X in the middle region. All guinea pigs are mammals means if anything's a guinea pig, then it is a mammal, and some guinea pigs exist. Therefore, there's got to be an X marking the spot where guinea pig mammals exist, and shading indicating the region that are not guinea pigs at all. Now let's go to the E form. And remember, we're still doing the Aristotelian perspective here, just so we have an idea of what it's like and how it's different from the modern perspective. What we're really aiming for in this video is the modern perspective. So as soon as I finish this, we're going to try to just keep in mind that there's this other way of doing Venn diagrams of using the Aristotelian perspective. And bear in mind, if you like the Aristotelian perspective, or even if you don't like it, whenever you encounter an argument where someone can be reasonably assumed to be talking about things that really do exist, like if I say all guinea pigs are mammals, therefore some mammals are guinea pigs, that you just include the extra step, the unstated implied step that some guinea pig statement that some guinea pigs exist, include that, and you're fine to work with the modern perspective. So once we go over this Aristotelian perspective, we keep it in mind that it exists. This Aristotelian Venn diagramming method. Once we go over this, we keep in mind that it exists, and then we forget about it, and we do Venn diagrams using this simpler modern way. All right, the Venn diagram for the E form of a categorical proposition, no S or P, would have the same three overlapping same three regions for two overlapping circles. One for the S term, one for the P term, i.e. the predicate and the subject and predicate terms. So if I'm saying no guinea pigs or hamsters, I'll have one circle for guinea pigs, one circle for hamsters, and they are overlapping such that there are three regions where you can include some information. You can put information in the guinea pig only region, in the guinea pig and hamster region, and in the hamster only region. Actually, you'll never want to write the information in the hamster only region. You want to know what that would look like, but that's not how you do a Venn diagram properly. You put the subject term on the left for a categorical proposition, and since there's only four, then you're never going to end up putting anything in the predicate term only region, because none of the four forms are like that. And if you're thinking, yeah, but what if I wanted to say some hamsters are not guinea pigs? Well, that's fine, but then you're going to have to switch around your circles. Hamsters will be the subject term. It will be the circle on the left. Anyway, no S or P means there's going to be nothing in the overlapping region. So you're going to shade that region. And since we're using the Aristotelian perspective, we're assuming some S's exist. You simply put an X in the S only region. So no guinea pigs or hamsters. If you're going to Venn diagram that statement using the Aristotelian perspective, you have an overlapping circle, two overlapping circles, one for guinea pigs, one for hamsters. The guinea pig circle goes on the left. And don't forget to label the circles. If I haven't said that explicitly, always label the circles. And you have the middle region, the overlapping region, shaded to indicate that no thing is a guinea pig and also a hamster. And then you put an X in the far left region, the S only region, indicating that some guinea pigs do exist. There are such things as guinea pigs, and nothing is a hamster and a guinea pig. Now moving to the I form proposition, it would look like this: two overlapping circles with an X in the middle. That's it. Very simple. So some S or P is the I form categorical proposition. For example, some guinea pigs are pets. Some guinea pigs are pets. If you're going to Venn diagram that, you have two circles, overlapping circles, one for guinea pigs, one for pets. Put the guinea pig circle on the left and put an X in the middle. We're not saying anything about guinea pigs that are not pets or anything about pets that are not guinea pigs. We are saying something about guinea pigs that are pets, namely that they exist. So put an X in the overlapping region to mark the spot where something exists, and that's it. That's all you do for that one. Now let's go to a Venn diagram for an O form proposition. And it's similarly very simple on the Aristotelian perspective, also on the modern, but we'll get to that in a moment. Let me think. Some guinea pigs are not pets, right? There are wild guinea pigs. Some guinea pigs are not pets. How do you Venn diagram that? Two overlapping circles, guinea pig circle on the left, pet circle on the right. Some guinea pigs are not pets is telling us that in that leftmost region representing things that are guinea pigs but not pets, something exists, so put an X there. That's it. That's the only thing that categorical proposition is saying. And that's all you would do for Venn diagrams on the Aristotelian perspective. And again, this could be done. This is a perfectly respectable way of doing Venn diagrams and testing arguments for validity, but we're not going to do it. We're going to do it a simpler way using the modern perspective. Now let me see if I can pause, take a break, have a sip of caffeine, and jot down a couple things I said that I don't think are currently in my notes. All right. I've jotted this much down. I think I may have still forgotten something that's not in my notes, but I think I said it, so hopefully we'll be okay. Don't forget to label the circles, place the subject term circle on the left. All right, now Venn diagrams in the modern perspective are much simpler. I hardly even need to say anything. For an A form proposition, all S or P, we just shade the leftmost region representing S's that are not P's. If anything is an S, then it's not a P. That's what an A form proposition means in a modern perspective, and that's all it means. Well, that's what it means on any perspective, but that's all it means on the modern perspective, so that's all you diagram. So if you're saying all guinea pigs are mammals and you're doing the modern perspective, you have two overlapping circles, one for guinea pigs, one for mammals, and you do the same thing you do for the Aristotelian perspective, except you leave out that X in the middle. The leftmost region, the guinea pig circle that's not overlapping with the mammal circle, is shaded to indicate emptiness. All guinea pigs are mammals means There is no such thing as a guinea pig that's not a mammal. That's it. Now, if you're saying no, guinea pigs are hamsters, or any other E-form proposition, you have a left circle for the S term, left circle for the S term, a right circle for the P term, a left circle for the subject term, a right circle for the predicate term, the left circle for guinea pigs, the right circle for hamsters, and the overlapping region is shaded, indicating nothing, non-existence, nothingness, emptiness, indicating there is nothing in that category of things that are both hamsters and guinea pigs. Don't put an X anywhere. For the I-form categorical proposition, it's exactly the same as in the Aristotelian position, overlapping circles, S term, subject term circle left, predicate term circle on the right, put an X in the overlapping region. For an O-form proposition, some S are not P, put an X in the region to the left, some S are not P. Some guinea pigs are not pets. Your leftmost circle will be labeled guinea pigs. Your right circle will be labeled pets. Draw the circles till they overlap, and in the overlapping region, don't do anything. In the leftmost region, representing things that are guinea pigs, but not pets, put an X, because that's what the proposition says. Okay? That is how you make Venn diagrams for categorical propositions. Now let's see what else is on our notes, and then I'll see what else I may need to fill in here. You must understand that when we're using the modern perspective, A&E statements are not saying anything about what exists. They're only denying that certain things exist. An A statement denies that there's an ES that is not a P. An E statement denies that there's an ES that is a P. You might be thinking an A statement is clearly an affirmation, not a denial. We say it's affirmative, not negative. Hang on. Universal, particular, affirmative, negative. Yeah, that's what we say, isn't it? So you might be thinking, why would it be a denial? Well, because it is. Some affirmations are denials. When I say all guinea pigs are mammals, I am denying the existence of guinea pigs who are not mammals. So a universal affirmation is in fact a denial of a particular sort. So the only issue is whether it's also an affirmation that such things exist. If you think it is, then go back and think about, go back to videos on existential import and learn what to do if you have an Aristotelian position. But for now, we are working with the modern position. We're saying that an A statement denies that there's an ES that is not a P, and that's it. And we're going to work with that hypothesis, that philosophy of language, and the corresponding methods of testing arguments for validity. But in brief, if you do think that a statement like all guinea pigs are mammals denies that any guinea pigs are not mammals, but also affirms that some guinea pigs exist, then you're okay. Just don't Venn diagram that much unless you also spell out the extra implied premise. Some guinea pigs do exist. All right, an E statement denies that there's any S that is a P. An A statement denies that there's any S that is not a P, and hence you have that shading. Another way of thinking through this, on the modern perspective, A and E statements are hypothetical. An A statement means if anything is an S, then it's also a P. An E statement means if anything is an S, then it's not a P. And that's it. That's all we have in our notes. But I think there's still more information I need to give you. And I think I can remember maybe all the things I need to give you that I haven't given you yet. Let's see if we can do it one at a time. First, I don't think I've said this explicitly, but a Venn diagram would be, oh, let's see, what's this? Good, that's good, mostly white space, we can work with that. A Venn diagram is going to be, well, it's going to be two overlapping circles, three if you have three terms. I was sure I could make shapes here, but now I can't find them. There we go, there we go. So here's a nice circle, here's another circle, and let's label our circles S and P. S for subject term, P for predicate term. And now understand what these circles represent. They represent all the possible relations, all the possible categorizations between S and P. And what those categorizations are hang on, I'm just trying to get my it's very odd what my Zoom controls are doing to me. It's very strange. I don't know what just happened there. Okay. I don't know what it thinks it's trying to do. Oh, did I click on eraser? I clicked on eraser. This is a waste of our time. Hang on. Sorry about that. All right, I finally got it in order. This is what I want to be able to do. I just want to be able to scribble on the screen. All right. When you have two categories and one is represented by one circle and the other is represented by another circle, and the circles overlap, that covers all the possible bases. It covers all the possible categorizations of S and P. It covers all the things that are S and P, that middle overlapping region. It covers all the things that are P and not S, the rightmost region of the Venn diagram. It covers all the things that are S and not P, that leftmost region of the Venn diagram. Now, if you're thinking, wait, what about the things that are neither S nor P? Well, actually, a Venn diagram covers that too. That's everything outside the circles. So a Venn diagram covers all possible combinations, things that are S and P, things that are S but not P, things that are, let's not do that finger motion, things that are S and P, things that are S but not P, things that are P but not S, things that are neither. All those different combinations are included in a Venn diagram. Our categorical propositions, though, will not make statements about anything outside the circle. That's theoretically covered by a Venn diagram, but we don't need it. A Venn diagram will only be needed to chart categorical propositions, which are only going to make statements about what is within the circles. Okay, now the next thing I wanted to clarify was this. You might be thinking, well, gee, shouldn't our circles not overlap if it's categories that don't overlap? So, for example, if you were talking about hamsters and guinea pigs, you think no hamsters or guinea pigs, and maybe you read a proposition that says no hamsters or guinea pigs, then you might be thinking, well, gee, I should label one circle the hamster circle. Remember, our terms need to be plural, so make it plural. Label one circle the hamster circle and one circle the guinea pig circle, and draw them separate, not overlapping. Well, there are certain times when you might find it useful to do that, particularly if you have to do work with four terms. But never mind that for now, maybe forever, never mind that. But understand, this is not the way we do Venn diagrams. We have shading to indicate a lack of overlap. Understand this, a categorical statement or a categorical syllogism needs to be able to consider all the possibilities. And when a premise of an argument rules out some possibilities, especially if it's an obvious one, like no guinea pigs or hamsters, no mammals or sharks or something like things like that, then you include that information in the Venn diagram, not by separating the circles, but by doing a standard overlapping circle and shading in the middle region. If they don't overlap, that just means your middle region needs to be shaded. This shading of a middle region, shading of an overlapping region, indicates there's no overlapping of the categories. The circles overlap, but the categories do not, because this is a convenient way we can represent all possible relationships. If two terms are such that the categories they refer to don't overlap at all, you represent that by having the circles overlap and then filling in the overlapping region to indicate that the categories do not overlap. Overlapping circles and overlapping categories are not the same thing. That was the most succinct way I could say it. But practically speaking, maybe the most important thing I need to say is just this. Draw your circles overlapping. Always draw the circles overlapping. Now, one other thing I need to do is make sure that we have some short commentary on using Venn diagrams to test immediate inferences for validity. And I find that's not in my notes. So I think I'll just add a quick video after this to cover using Venn diagrams to test immediate inferences for validity. I'll just do that quickly in the next video. All right, now let me think. Do I want to give you any bonus information? I might as well try. If you don't want anything extra, stop here. Don't keep going. But anyone who cares, you can only have a 3-circle Venn diagram or a 2-circle Venn diagram. Now, in theory, you could have a 1-circle Venn diagram to talk about, I don't know, peanuts, for example. 1-circle diagram to talk about peanuts, and you can say peanuts exist and put an X in the peanuts circle, or some things are not peanuts and put an X outside of the peanut circle, or all things are peanuts and shade the infinite space outside the circle. That's a ridiculous sort of statement. Or nothing is a peanut, no peanuts exist, and then shade the interior of the circle. In theory, you could have a 1-circle Venn diagram. I guess a 0-circle Venn diagram might make some sort of theoretical sense if you're talking about no categories at all. But practically speaking, the only 2 numbers of circles that make any real sense are 2 and 3. Here's why. A first circle bisects everything that exists into 2 categories, things that are within that circle and things that are without that circle. And what that symbolizes is a division of all things that exist into either the category of things represented by the term the circle represents, or the category of everything else. The circle that represents all guinea pigs divides reality into things that are guinea pigs and things that are not, things that are inside the circle, things that are outside the circle. We bisect reality in that way with that sort of representation, that sort of symbolization scheme of a Venn diagram with 1 circle. So now a Venn diagram with 2 circles, since Venn diagrams are supposed to represent all the possible relationships among categories, a 2-circle Venn diagram means your second circle has to bisect all the other categories, which means it's got to bisect the category which is within the first circle and the category of things outside. Now, we're not talking bisect in math class where we have 2 equal shapes of equal area. No, I just mean divide into 2 different subcategories. So if I'm drawing a circle for guinea pigs and a circle for teacups, obviously the overlapping region is going to be shaded because no guinea pigs or teacups, right? And I'm drawing a circle to represent the category of guinea pigs and the circle to represent the category of teacups. My first circle for guinea pigs is going to divide all reality into things that are guinea pigs, things that are inside that circle, and things that are not. And my second circle, teacups, is going to divide all reality, again, things that are teacups and things that are not. But in order to cover all the possible relationships, it's got to bisect the area within that guinea pig circle and the area without. And so you have to have the overlapping circles. First circle represents all things that are guinea pigs. Next circle represents all things that are teacups. And the first circle divides reality into guinea pigs and non-guinea pigs, things within and without the circle. And then the second circle, in its region that's outside the guinea pig circle, is going to represent things that are teacups and not guinea pigs. And the things that are outside both circles are going to represent things that are not guinea pigs or teacups. And in this way, the teacup circle bisects the category of things that are not guinea pigs. But in its overlapping region, it's going to bisect the category of things that are guinea pigs. So first circle represents guinea pigs. Second circle represents teacups. And by making that circle overlap with the guinea pig circle, we've divided the guinea pig circle into things that are guinea pigs and not teacups, things that are guinea pigs and aren't teacups. So every circle bisects all the categories. Every new circle you draw in a Venn diagram is going to bisect all the categories that you already have. I really should have been charting this as I go. So here's a circle, and it divides reality into things that are guinea pigs and things that are not. And I pause, waiting for my computer to decide whether it's going to let me change the font size. Okay, next circle bisects reality into further categories. It bisects this category of things that are not guinea pigs, the outside the circle, into things that are not guinea pigs or teacups, and things that are not guinea pigs are teacups. And then within the guinea pig circle, it's bisected the guinea pig category into things that are guinea pigs and things that are guinea pigs and teacups. So now our third circle, if we add a third circle, it's going to have to bisect all the other categories. It means we're going to have to bisect this region, and we're going to have to bisect this region, we're going to have to bisect this region and this region. It's going to have to divide into two all four of the pre-existing regions. So our next circle will represent, I don't know, Labrador puppies. So now we've taken our region of things that are guinea pigs and we bisected it to represent things that are guinea pigs and are not Labrador puppies, things that are guinea pigs and are Labrador puppies. And then we've taken our region of things that are guinea pigs. Sorry, that was guinea pigs only. Now we've taken our region of things that are guinea pigs and teacups and we bisected things that are guinea pigs and teacups but not Labradors, things that are guinea pigs and teacups and are Labradors. And then we've taken our region of things that are teacups and not guinea pigs and we bisected it, things that are teacups and not guinea pigs and not Labradors, things that are teacups and not guinea pigs and are Labradors, and then things that are neither guinea pigs nor teacups, we've bisected that again, things that are not guinea pigs, not teacups, and not Labradors, things that are not guinea pigs, not teacups, and Labradors. Each circle has to bisect all the pre-existing regions. And that's why you cannot have a Venn diagram with 4 circles. It can't be done. How on earth can you draw another circle that's going to bisect all of these categories? Now, when I thought about this, teaching a logic class or critical thinking class or something years ago, I realized, well, it is sort of possible to draw some kind of Venn diagram. It's just not going to involve circles, and it's going to be hideous. It's going to be something like this. It's going to be some hideous amoeba shape. Here I bisected the outer region. Now I'm bisecting the teacup only region, now the teacup guinea pig only region, now the teacup Labrador, guinea pig Labrador, not teacup region, now the guinea pig Labrador, teacup region, now the teacup Labrador, not guinea pig region, now the Labrador only region. So with the Venn diagram that looks like this, with this hideous amoeba or something drawn over everything else, you could in theory bisect all your pre-existing things. This is how you would have to do a Venn diagram with 4 categories. So just basically never do it, only 3 circles at a time. If you have to work with an argument that is more than 3 circles, more than 3 categories, that's fine. That's called a Sorites. You'll just have to do separate Venn diagrams for your extra steps of the argument. First 3 categories can go in their own Venn diagram, and then you can do some other Venn diagrams for other steps of the argument using other categories. Now, I feel like there's something I forgot to explain, and I don't even know what it was. Ah, yes, I was going to do one final thing. Let's just finish stating what is true about the categories of guinea pigs, teacups, and Labrador puppies. There is no such thing that's a guinea pig and a teacup. So both of these regions are empty. There's no such thing as a Labrador that's also a guinea pig. So that region is also empty. And again, we have an extra reason to shade the region in the middle. And then this other region, teacups and Labradors, but not guinea pigs. You got to shade that too, because there are no Labradors that are teacups. But do guinea pigs exist? Yes. So that is necessary for writing in the full truth about these categories. Do teacups exist? Yes. Do Labrador puppies exist? Thankfully, on both points, yes. Now, there's some things that are none of these. Yep, actually, there are. There also are such things as peanuts, which are not guinea pigs, Labradors, or teacups. So that's the completed Venn diagram for the truth about all 3 of these things. All right. Thanks for watching.